Okay, so your bell work today, I ask you to get out your assignment from last class period and work problem number 9, error analysis. So when we look at that, it says, I think I wrote it somewhere, did I? No. Okay, so on the error analysis, it said, a classmate said that the sum of 4 over x squared minus 9 plus 7 over x plus 3 is equal to 7x plus 25 over x squared minus 9. So what mistake did they make? Could anybody tell me what mistake they made? And what is the correct answer? This is just review of what we did last week. How do we add these two numbers? What do I have to do in order to add these? The denominators have to be the same. Very good. And they're not the same right now, right? So sometimes we have to undo things to see how to work them. So if we look at this, you should recognize that right off the bat. That's a difference of 2 squares, and we can quickly factor that into x plus 3 times x minus 3, right? So if we have an x plus 3 times an x minus 3 in this fraction, so let me just rewrite it real quick. 4 over x plus 3, that's not a negative, that's fine. X plus 3 times x minus 3, and I'm adding to that 7 over x plus 3. Well, what do I need to do to the second term to make it match the first term denominator? Yes, very good. Multiply by x minus 3. Alright, and if I do that to the bottom, I have to do it to the top, because what did I do here? I just multiplied this by 1, because x minus 3 over x minus 3 is 1. So I multiplied our second fraction by 1, but I made 1 fit our needs to create a common denominator. Okay. So now let me get rid of my little arrow, and it's not going to let me. Okay, so let's continue on. Now I'm just going to do a straight copy of my first term, 4 over x plus 3 times x minus 3 plus, and now I'm going to have 7 times x minus 3, right, that one, over x plus 3 times x minus 3. Now, my denominators should match. X plus 3 times x minus 3, x plus 3 times x minus 3. So, voila, we've got a good start here. We've got common denominators. Now we can continue to simplify our fraction. Now, what I'm going to do next is distribute my second term. So this right here becomes 7x minus 21 over x plus 3 times x minus 3. And we still can't forget our first fraction because we're just adding these two, over x plus 3 times x minus 3. Everybody with me so far? Now when we add these, now that my denominator is the same, I can basically just write it as one fraction now. X plus 3 times x minus 3 all over 4 plus this. 7x minus 21. Okay, now when I do this part, let me switch colors. Now get my like terms of 4 and minus 21. There's my like terms. So I need to combine my like terms. So I'm going to keep my 7x because nothing happens to him, so he's done. Now I've got to combine negative 21 plus 4, which gives us a negative 17 over x plus 3 times x minus 3. And that's it. That's our answer. That's what it should be. So let's scroll back up and see what our fellow did wrong up here. Our classmate. Could be a guy or a girl, right? So they had 7x plus 25. What mistake did they make as we scroll through this work? How did they get a 7x plus 25 instead of minus 17? You'd think the error happened in the second term, of course, but what did they do? Does anybody see the mistake they made? They added it, but what caused them to add it? If they had a plus sign here, they must have multiplied to begin with by x plus 3 instead of x minus 3. Do you see that? So if they added, or if they multiplied everything by up here, if they made that a plus instead of a minus, you would have had 21 plus 4. Or they could have multiplied it right and just like you said, just missed the sign. So either one of those would have been correct, which caused them to add 21 and 4 to make a positive 25. Okay? So any questions? Simple little math problems can turn into big monsters sometimes, and when there's lots of little calculations, it's easy to get the whole answer wrong when you just miss one little sign. So be careful about those little things. Okay? Any questions before I move on? Okay. I'm going to group this whole thing so I don't lose it. So today we're going to move on and talk about complex fractions. So what is a complex fraction? A complex fraction is a rational expression that has at least one fraction in its numerator or denominator or both. So let's see. It says it's going to have a fraction. Here's a big fraction, right? Here's my numerator. My numerator has a fraction plus a fraction. My denominator has a fraction. So it's basically a fraction within a fraction of a rational number, which means you've got to have x in the denominator. Let's look at the next example. So here we've got a big fraction. My numerator has a fraction, and my denominator has a rational fraction. So fractions within fractions. And then it's going to have a fraction in the numerator, the denominator, or both. Now look at this guy. This is a monster. Right there. A big one. Monster, as they say up east. It's a monster. So we've got a complex, really complex fraction here. There's a lot going on in the numerator and a lot going on in the denominator. So when you think about it in terms of trying to simplify these and to clear them and get them down to x equals something, which is where we're eventually headed, but today it's just about simplifying these things. How do we make these not so complex? And it comes down to factoring and canceling out, factoring and canceling out, and following a few math rules. Okay. So let's look at problem 4, and this is going to start the back side of our assignment 8-5. This goes with problem 10, 11, and 12. And it says, what is a simpler form of the complex fraction? So let's look at how are we going to work with these things. Well, we've got a fraction plus a fraction, pretty simple, over a fraction plus a whole number. Well, we can turn any whole number into a fraction, right? Just put it over 1. Now we've got 4 fractions, 2 on the top, 2 on the bottom. So I can tell you there's lots of different ways to do this. We could do our math rules and find common denominators, but it would get really tedious. What if I told you we could do this the down and dirty, just quick, fast, simple way is to find 1 each of the denominators and multiply everything by that. Let's see. Let's get a denominator. What are our denominators in this? We've got an x and a y, and then below we've got a y, and I turned that one into a fraction, so a y and a 1. Well, we already have y, and now we've got 1. So when you multiply all these together, you just get 1xy, or we don't write that 1, we just say xy. So I'm going to multiply every single term here by xy. So just get 1 each of your denominator, multiply everything by that, and you'll wipe out all of your denominators. And then we end up with a simple fraction. So here's what we're going to do. We're going to multiply by xy over xy. And there it is, right there. That step right there. They're multiplying this whole thing. The numerator by xy and the denominator by xy. But remember, because there's more than one thing here, it's best to use parentheses. Okay, and that's what they've done right here. Now our next step, now we're going to distribute this xy to both terms. So it's going to be 1 times xy and 1 over x times xy and x times xy over y. So that's what's going on here. Let me clear that up. And then we're going to distribute this xy to these two terms. 1 over y times xy and 1 times xy. So we've multiplied everything here by that xy. Now, what they didn't show is how they simplified from here. So let me go to my next page. This is a blow up of this step right here. All right, so let's now do this. So that's going to become xy over x, right? Because it's like xy over 1 times 1 over x. So it becomes 1 times xy over x times 1. That. Okay. Next, we're going to add, and then xy times x over y. Okay. So now the numerator's done. Now let's do the denominator. Xy over y plus 1 times xy is just xy. So we just distributed that xy to every single term. Now I'm going to change colors here. Now let's cancel out. So in my first term on the numerator, the x's cancel out. And the second term, my y's cancel out. In my denominator, this y cancels out, and then that's it. Now you see what we've done? We've basically canceled out every denominator, so we end up with a much simpler number. So now simplify. So we've got a y plus x times x, which is x squared, over x plus xy. Oops, my x went rogue there. I don't know what happened, but it just had a mind of its own. Alright, so there's my answer. That's how easy that is. So pick one each denominator, multiply everything by those, and it clears out all your fractions. It knocks out all of your denominators. Okay. Let's look at number 10 on your homework on the back side of your paper. Number 10, we have 1 over x plus 3 all over 5 over y plus 4. Okay, so let's turn everything into a fraction. Now let's get all of our denominators. So what do we have? An x, a 1, a y, and a 1. Now let's write those. X, y, and we only write them once each, and 1. So again, we've just got a x, y. See that? So now multiply both numerators and denominators by that x, y. Alright, so take a moment and do that, and we'll come back. I'm going to pause the video. Okay, now we're back, and I've asked everyone to share their answers with their aisle partners, their aisle buddies, and I heard a little bit of discussion, but not a lot, so that concerns me. What are we going to do with this xy here? Well, it's going to go here, xy, and then this will be 3xy, right? So that gets distributed. Now let's distribute this one. So it would be 5xy plus 4xy. Okay, so that gets distributed to everything. Now we will do what? Simplify. The x's cancel out. Nothing cancels out on the second term, so we're left with y plus 3xy on top. All over, and the y's cancel out here, and we're left with 5x plus, whoops, plus, and then 4xy. And that's it. And I've had some people say, well, why can't you cancel out these xy's? It's like, well, you can't, because you've got to have an x, y, and everything to cancel it out. Because let's think of these like a piece of a puzzle, and this is one piece of the puzzle, and this is one piece of the puzzle. We can't break it in half and say that's going to fit. Okay, that's a binomial, so you can't just solve one part of the binomial and ignore the other part. Okay, so that's your answer right there. Any questions? Don't make it harder than it is. Okay. Let's go on to the next problem. Oh no, that's the one we just did. Okay, so what I'd like for you to do is just work 10. We just did 10, so do 11, 12, and 13. And 13 says what numbers are not in the domain, which means what can x not be in this. Let me see, I've got it written right here. This is number 13. What real numbers are not in the domain of the function? So you have to think, what can x never be? What would cause that to break a math rule? Okay. So work 11, 12, and 13. It shouldn't take you 4 minutes to do, so I'm going to set the timer for 4 minutes and then we'll come back. I'll pause the video now. Okay, so we're back, and I ask everyone to work 11 and 12 and talk about 13, what real numbers are not in the domain of the function. So if you would turn into your IO buddies and discuss what, I can give you the hint that it's 3 numbers. Oh, I locked it, sorry. But it's those 3 numbers right there. This isn't going to change. So let me unfreeze it. There we go. So it's those 3 numbers right there. Or excuse me, this problem right here, but the 3 numbers, you're going to give me 3 different answers. What can x never be? So x cannot equal what? X cannot equal what? And x cannot equal what? Alright, so discuss that with your IO buddies. Come on guys, I want to hear talking. If you don't know where to start, tell your neighbor, I don't know where to start. Maybe you guys can help each other get started. Okay, so I don't hear a lot of talking, so I'm going to go ahead and move it on. If I've got a fraction, 5 over x, what can x never be in this fraction that I'm showing you in the corner? 0. So what if I had 5 over x minus 2? What can x not equal? 2. So anything that makes a denominator 0, that's what's going to go in my answer, right? This is all we're talking about here. What is an illegal move with these numbers? So let's look at all the fractions we have. We have this fraction, we've got that fraction, and we've got this fraction. So each one of those are going to come up with different values of x. So let's work on the first one. What can x never be in my numerator? What could x never be? 2. There's your, well, actually it would be a negative 2. Because if I have a negative 2 plus a 2, that gives me a 0, which we can't have in a denominator. So we're going to say x cannot equal negative 2. So there's our first one. So done with that part. Now let's look at the bottom one. What can x not equal in this part? Negative 4. Okay, so what, this whole fraction is still in our denominator though. See that? So even if I had a valid fraction like 0 over 5, if that's in a denominator, it's still giving me a whole denominator of 0, which is wrong. So what else can x not be that would turn this whole thing to 0? I think I heard it. Negative what?
3.
Yes, there you go. See, you guys had it all along. Good job. Even though, if we had a negative 3, let's go negative 3 and negative 3 for x. So we would get a 0 over a 1, which is a valid number. It's a valid fraction. We can take nothing from 1. But when you look at the big picture of things, this 0 isn't a denominator. So we can't have that. So, okay, that's your answer there, guys. Any questions about that? Okay, so on number 11, we had negative 3 over 5 over x plus y. What are we going to multiply our numerator and denominator by? What's our only denominator in x? Okay, and so this is number 11 in your book. So then we get what? Negative 3x over, and then we distribute this x to both terms, 5x over x plus xy. And then what cancels out? These. So my final answer is negative 3x over 5 plus xy. Okay? The last one, I'm not going to work the whole thing, but you had 4 over x plus 2 divided by 3 over x minus 1. So you know you're going to multiply both sides by x plus 2 times x minus 1. Well, actually, I can work the whole thing. X plus 2 times x minus 1 over x plus 2 times x minus 1. Okay? And when you do that, let's see, can I break this up? Oof, not very good. All right. So this goes up here, and this one goes right there. Okay? Now, what happens from there is, now this extends and this extends. So our x minus 1's cancel out down here, and my x plus 2 cancels out up here. So I'm left in this big fraction of 4 times x minus 1 all over 3 times x minus 2, or x plus 2. And that's your answer. How simple is that, guys? No number crunching. It's really just a little bit of guess and check, basically, but we're not even guessing. Your answers are right in front of you with those denominators. Basically just write your denominators, cancel out. Your answer is whatever's left over. Okay, any questions about those? Pass that forward real quick, and we're going to do a quick quiz. And I'm going to give you a note card. Pass them up and then down. Make sure you put your name and your hour in the upper right corner of your card. This is just a one-question quiz. Do I have anybody's stuff? Thank you. Paper? Thank you. All right, got everybody's stuff. I'd like a nice thick stack of papers. That's happiness to a teacher. More work, but it's happy work. All right, so what we're going to do, you've probably already done it if you worked your assignment all the way through. It's number 15 on this assignment. And number 15 is just one of those little quick things. Let me find it. Simplify. It's what we've just been doing here, right? So you're going to simplify this fraction. 2x minus 5 over 6x minus 3. So we just worked 3 problems just like that. So simplify this, and it's just what we were doing, okay? So don't panic and make it something different. Right? Okay, and then that will conclude our class. I'm going to go ahead and stop the video, and tomorrow we'll move on to 8.5. and excuse me, 8-6, and that will be split up into 2 days, and that's our last of this chapter. Now 8-6, we do a lot of number crunching in 8-6, so, but it's easy stuff. All right, this concludes our video. Thank you.